In this video, we'll be looking at a more complicated example of the limit definition of a derivative. You'll notice this example is a cubic, so it's not nearly as easy to simply look at it and say, well, if it's a line function, a linear function, I can say that the slope is based on this, the actual slope of the line. Well, the cubic function actually has a very smooth curve to it, which means that the slope at any given point should be variable. It should change at every single x value. Well, if that's the case, I guess we better go through the steps of identifying what is g prime of x. So you'll notice here that, again, this function is g of x. Well, if I change the variable or the function, I have to calculate appropriately for that. But the prime notation still refers to derivative. So right here, I'm going to go ahead and identify what my g of x plus h is. I'm going to do this outside of the actual limit setup of the derivative, because this particular problem looks much more obnoxious in terms of its algebra. The first step is easy, me just distributing this -5. This step over here, I'm going to have to actually write this thing 3 times. So it'll be something along the lines of this, and I'm going to move it over here once I get there. -2 x plus h times x plus h times x plus h minus 5x minus 5h. And again, the reason why I did that is so that this negative stuff would be distributed smoothly and I wouldn't forget to do that, and then so that I have this stuff viewed easily to deal with. Now, if I'm multiplying 3 or 4 numbers together, recall you would multiply 2 of those numbers at a time and then take that new number, multiply it to the third. So that's actually what I'm going to do right here, is I'm going to group these 2 terms together first. I'm going to multiply out those 2 first. I'm going to do that over here. So I'm going to have 2 times, when I multiply these 2 pieces out, it's x squared plus 2xh plus h squared, and I'm still multiplying that thing by the x plus h. So now that I've done that, don't forget your minus 5x minus 5h. I then need to go ahead and distribute out the x to all of these terms, distribute the h all of these terms. Now you could take the x squared, distribute to both terms, the 2xh squared distribute both terms, and then h squared distribute both terms. But I'm a little bit lazy and I just wanted to go ahead and do one distribution 3 times and one other distribution 3 times. The 2 here, I'm going to leave it until the very end. I don't want it to muck up any of my algebra, and I think that could make some mistakes. So the 2 is going to stay, and I'm going to put brackets around my new remaining stuff. I'm going to distribute the x first, giving me x cubed plus 2x squared h plus xh squared. That's me distributing the x. Now I'm going to distribute the positive h, giving me plus x squared h plus 2xh squared plus h cubed. I'm going to put that in brackets, and I'm going to subtract the 5x and the 5h. And after I've done that, I will now combine like terms in the center and distribute the 2. Be very, very careful when combining these like terms. This is 2x cubed. I have x squared h, but I have xh squared, and those 2 terms are different. I have to look for all the terms that have an x squared, there's an x squared there, and an h, that also has an h. So I have 2 of those terms here, and I have 1 term here. So that's plus 3x squared h, that takes care of this term. And this term, I'm going to go ahead and put check marks next to it so it doesn't look like an x. I've taken care of this term. Then I'm going to have xh squared plus 2xh squared, giving me a total of 3xh squareds. Took care of those 2 terms. And then plus the h cubed. Now I have minus 5x minus 5h. I can distribute the 2, and then I will have this thing entirely simplified to what it really is. This right here is actually the majority of all the work you're going to have to do, is making sure that you can algebraically simplify this x plus h cubed efficiently. So g prime of x is going to be equal to the limit as h approaches 0 of g of x plus h minus g of x, all divided by h, which I will simplify that limit right now as I plug the things in. Distributing that 2, giving me 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 5x minus 5h. Do not forget that this right here, I'm putting it in brackets to emphasize it, is simply this piece. I still need to subtract from that the original function, unchanged. This is all divided by h. Now, as we look at this, we should notice that the negative distributed into both those terms. We'll change this to be, something went wrong. There's a negative on this too right here, which means that this is a negative, which means that this is a negative, that this is a negative, and all of these terms that were multiplied by 2 have a negative in front of them. They are not positive. It's extremely important that we pay very close attention to the functions that we have and how we make sure we don't make any silly mistakes with those negative numbers. Now, In this case, I will distribute this negative over here, making this a positive term. And the reason I knew that I made a mistake was because this x cubed term and this x cubed term have to cancel out. Otherwise, I can't factor an h out of all of the terms on top. Okay, more importantly, all of the terms in this second set, when distributing the negative, should find its corresponding value such that it's an alternate sign. Negative negative is positive, so this negative cube cancels out with this positive cube cancels out with the negative cube. Then negative to negative is positive. This positive 5x will cancel out with this negative 5x, leaving me with a limit as h goes to 0 of negative 6x squared h, making sure I don't forget any of those negatives this time, minus 2h cubed minus 5h, and there's no other terms left on that side, all divided by h. You can, again, avoid factoring, but be very, very careful when you do so that you remove a power of h only from each term. Again, if you do not remove a power of h, or remove more than just a power of h, things are going to get really, really bad, and the value will end up being wrong. So now as h goes to 0, this term is going to go to 0 because it's got an h still left in it, and this term is going to go to 0 because it's still got an h left in it. And therefore my final result is negative 6x squared minus 5. This is g prime of x. Again, these problems require an immense amount of algebra to execute them efficiently and carefully. Please make sure that you do the same, and you are very diligent about checking your algebra work to make sure you don't make any silly mistakes.